By the way, I got to tell you, I'm really interested to see how Lufthansa does Turkey on the airplane home. We'll see if it's any good. All right, so this is your team instrument rated or deploying 89,000 times per day? So a lot of times we talk about, and a lot of the conversations that we have about DevOps are related to tools and culture, and specifically organizational culture, right? We talk a lot about culture. We spend a lot of time thinking about it. And this is a slide from Damon Edwards' presentation in DevOps Age Rome in 2012. It's quite an old presentation. And he was saying, this is the state of the art in culture, DevOps culture in one slide. Give everyone a hug and buy everybody a beer, right? So let's talk about culture for a moment, because this is maybe not the best definition of organizational culture. So what is organizational culture? Set of shared mental assumptions that guide interpretation and action in organizations by defining appropriate behavior for various situations. Now, grab this from Wikipedia via Damon's talk. Now, this is a fine definition, but how do we actually apply this in our organizations? Because culture is such an expansive term, I think we need a better definition. So for the purposes of this talk, I'm going to define culture as the incentives in your organization plus human factors. So what I mean by that, these are organizational, behavioral, and economic incentives. Things like, do you get a bonus for shipping this release by the end of the quarter? Or does your team get some reward for doing a particular thing? And then also, the methods by which we facilitate those incentives and foster them. So that's the human factors part of what we're going to be talking about. So who am I? I'm not going to go through this slide. I'm going to point out two interesting little details. I am J. Paul Reed on Twitter, so if I say something confusing or weird, or you want to talk with me about it on Twitter, that's totally cool. I hang out on Twitter, so we can chat there if you'd like. And then also the last bullet point, now they kind of call me a DevOps consultant, but I'm getting my master's in human factors and system safety. And the reason that I mention that is because a lot of this stuff comes from the safety sciences, a lot of the things we're going to be talking about. So you might say, well, why aviation? Why would we even talk about aviation? Why would we make that connection between that and DevOps? So when we look at how humans sort of pursue endeavors, they kind of go through this path from craft to where it's people involved on their own trying to perfect a craft, right? To a trade where a group of people do that, and they get together, they share domain knowledge. Then we get to sort of a science where it's consistently repeatable in different environments, and then we can optimize it, right? We can reduce and combine those different processes and put them together in an industrial or business context. Now, it's interesting to ask, where would you put Agile on this progression, right? Is it a science? Is it always reproducible? And then, of course, you could ask this about DevOps as well. Is DevOps reproducible in all of our organizations? I think the answer is pretty clear, because if it were, we wouldn't be here trying to talk about it and try to figure it out. So point is that we started looking in DevOps at other areas, other human endeavors, to help push sort of the state of the art of our practice. There's been a huge focus on incident response in the DevOps community. So how do we deal with incidents? How do we do incident management? And it's interesting, you can get workshops and trainings from firefighters that teach you how to do incident management in IT and bring sort of the practices that they do to what we're trying to do. So we're integrating knowledge from these different disciplines is often learned under very difficult circumstances, very costly circumstances. That's super important, but the problem is when we're talking about something like incident response, the house is already on fire, right? We've already sort of have a problem. So the question that I sort of had, are there other operational models that we can look at to sort of see what would be relevant in a DevOps context, and then take that away and maybe try to apply it to some of our practices, and that describes sort of the day-to-day normal operations that might be useful for us. So in all of these conversations about how to facilitate work and cooperation between development and ops teams, a couple of familiar patterns for me sort of occurred. This idea of developers as pilots and operations as air traffic controllers, right? Pilots and developers are ones who sort of utilize the system to execute a specific process under often very dynamic circumstances, right? Ops engineers and IT departments as controllers, sort of this idea that they're responsible for building and maintaining a pipeline and defining some operational policy so that the throughput, the number of flights or the number of deploys, can be maximized. So is this a possible way to sort of model what we might talk about in terms of a DevOps practice? Well, let's take a look. This is actually, these are old numbers, but in 2012, the FAA reported a staggering 138,000 operations a day. So that's about 86 deployments if you consider an operation a deployment, and that's a landing or a takeoff per minute. So when you think about it, both of us integrate different types of technologies and equipment, and we support a wide range of consumers. And from a complexity standpoint, the challenges that we face in our work really mirrors what the National Airspace System deals with every day. One of the other things, too, that's similar, a storm in the cloud ruins both of our days. All right. So when I say, is your team instrument rated, you might say, okay, well, what does instrument rating mean? So I want to talk about a little bit about the different sort of ratings. So what do we mean by that? You might say, well, don't all pilots use instruments? And we do, but the difference with visual flight rules is really it's based around being able to see outside the window, being able to see other aircraft. In fact, they call it see and avoid. The entire rating is basically based on the ability to see outside the window and keep your plane flying the way that you want to be flying it by being able to look at the ground and see the ground. So if you look at the maps, this is a visual flight rules map, you'll notice, and by the way, this is San Francisco, where I'm from, you'll notice that things like lakes, dams, highways, railroad are mapped on this because you're supposed to be able to see those things. If you're wondering what that yellow stuff is, that's what it would look like at night. That's light pollution from cities. So if you're flying around, that's where you would see the cities. And then, of course, for landings, you have to be able to see the runway. There's a bunch of rules about where the clouds can be and how high the clouds have to be and all of that. Instrument flight rules are basically everything else. I mean, obviously, they're different, and it's basically every other situation. But more than that, it's really an entire system that is designed for us to be able to take off, get to our destination, and land without ever seeing the ground or another airplane, which is kind of interesting if you think about it. So to that end, this is the exact same map of San Francisco, but it's really hard to tell where the bay is, where the ocean is, where the water is. And they don't bother drawing it on this map because the idea is you couldn't see it anyway, so why draw it? You'll notice the big things they emphasize here are navigation beacons and markers and airways and things like that. And then, of course, landing is an entirely different procedure and process altogether. That's an approach procedure, so that's what it looks like. It's a much more detailed map about how to land. And so it really is a holistically different way of operating an aircraft in terms of visual rules versus instrument rules. And in fact, it's often called, when we talk about it, flying in the system. You're actually sort of flying in a different type of system. And it requires a level of precision that is far greater than if you're just flying with visual flight rules. Now, I know this might seem kind of confusing and you might be trying to wrap your head around it, so I want to show you a video that might help with this. So, by the way, this is me flying. As you can tell, it's visual flight rules. It's a pretty day. This is up on the California coast. And I'm coming in for a landing there. It's a little windy. Right at the end there, you're not really sure what's going to happen there. And finally, you're down. Clunk. We landed. Now compare that to this. Now they're going about 150, 160 miles an hour here. You'll see a call out of they are 300 feet above the ground. This is what they can see. Can you imagine going 160 miles an hour? Being able to see that?
200. Runway side landing.
And of course, the other major difference, you can definitely tell when they've landed as opposed to my landing. And they are down. So I have a question for all of you. Which plane would you rather be on? The other thing that I would ask, as professionals, right? We're all technology professionals. Which plane would you rather be flying, right? You want to be the best expert you can be in the field that you practice, right? We'd probably want to be on that second one. Has anyone ever had a deployment like that my landing, where it's like it's almost deployed, maybe, kind of, and then it's yeah, I've had plenty of those types of deployments. All right, so let's talk a little bit about this idea of an instrument rating, what it sort of means. So, standardization. Now, I do not mean let's come up with a process for. I don't mean process is the answer to everything. But what I do mean is at least discussing and thinking about sort of some of our process primitives, some of the things that we care about as an organization. So this document is a big, huge binder, and it's called the TERPs. And basically, it is the list of requirements for every approach procedure that is defined in the United States. So it's going to list rules about what is the obstacle clearance, right? How much clearance do I have to give between like a building or a mountain or something like that? It's going to give rules about airspace protection. So around big airports, how many miles do I have to give between aircraft and things like that? Because I can't see them, right? So if you think about it, these are actually incentives. This is what the FAA and the National Airspace System is optimizing for, and this is also how they communicate them. So in DevOps, these might for us be things like unit tests or code style guidelines or deployment requirements, right? Non-functional, we talk a lot about non-functional requirements. It might be non-functional requirements. So once you have these primitives that are things that you care about in your organization, every deployment must meet these standards, right? Then you can actually use them for specific processes or specific operational procedures. Now, why would you bother doing this? Why would you spend that time to do it? Well, there's two reasons. The first one is you can scale it in different environments, right? So this is an approach plate to Aspen, I think it is, Aspen, Colorado. And so you'll notice there's lots of mountainous terrain, right? They are really worried about you flying into a mountain, so they chart it, and the procedures have a bunch of weird loops in there that have to do with where the mountain is. Now, if you compare this to a national airport in Washington, D.C., you'll notice it's a very different procedure, but they care about different things. They care about you avoiding things like the Washington Monument and the White House, right? So they draw different things. But what's interesting is that both procedures meet that TERPs document, right? So you know if you're using one of them, you have a basic set of guidelines and things that you know are going to be protected in both cases. So you don't have to think about it for every single process you come up with, right? And you can do processes in different environments that you know are going to be include the things that your organization cares about. It also means, though, that your consumers, so for us it might be operations, it might be developers, they don't have to know all of this either. They know that every approach that they fly is going to meet those requirements. Now, sometimes, for some reasons, an approach doesn't, and they'll mark it. Like, you need to have an additional power or a certain type of engine or certain equipment on board. And they can mark that on the plate so that when you're actually doing your work, maybe doing a deployment, it's things like, oh, this has an extra service, so be more aware or be sure that you think about that when you're doing a deployment. All right, communication, the second, what is it? We talk a lot about communication, especially in DevOps, but in this case, I mean precision of communication. And I think oftentimes we really underestimate its power. So in aviation, they take communication really seriously. This is a clearance. This was the first Virgin America flight from San Francisco to John F. Kennedy Airport. And their radio, they usually do this on the computer, but it wasn't working that day, so they actually had to read it over the radio. So this is their clearance that will take them from San Francisco all the way to New York. They'll probably, the flight will involve somewhere around 20 to 30 people as they cross the country. And this sets the expectations for all 30 people about what to expect out of that flight. Now, what's interesting about this is when you have this precision of communication, one of the things you can do is actually encode it. That is the exact same clearance, but it's in encoded form for pilots and controllers to read. But then the other thing, we talk so much about automation, right? So if we think about the procedures and the processes, and then we think about how we would describe them, then we can actually automate it. So if you're curious what that departure procedure is, that's the definition for it. And it also means that somebody in an A320 can put it in their flight computer and fly it. But if I wanted to fly it in my Cessna, I could pull it up and fly it. And yet the controller just has to say to me, you're going to fly the San Francisco 8 departure. Actually, this was the San Francisco 9 departure. So in other words, we're really trying to avoid this situation.
Starway 067 Heavy, County Tower, caution turbulence, 22 right, position and hold.
We're clear to line up and wait, runway 2 to right, Starway 067.
In position and hold, 22 right, Starway 067.
Yes, we're clear to line up and wait, Starway 067, runway 2 to the right.
Yes, position and hold. Jumper 677, breezy point climb, contact near departure.
Roger, Jumper 677, we'll see.
And Starway 067 Heavy, just we're on the same page, position and hold on 22 right.
We position and hold runway 2 to the right, Starway 067.
Finally got him to say position and hold. So it's interesting, right? There's a couple funny things. I think that it's funny that the controller's taking the time to have this argument with a pilot and still directing traffic, right? But the other thing is, this clip's what, 30 seconds? It took 30 seconds to communicate what should have been about a 6-second transmission, just because I think Starways is a French airline, just because the French pilot and the American air traffic controller wanted to argue about it, which I thought was kind of funny. But you know, not all of these cases are as humorous, right? I want to give a couple of examples of communication problems. So there was a flight actually arriving into JFK, and this was, I believe, in the mid-90s, where the flight coming in was low on fuel. They didn't use the words declare an emergency. We declare an emergency. They didn't use those words. Those words have very specific and special meaning in aviation. And so that the air traffic controller vectored them all around, and they ran out of fuel and then crashed. Misuse of defined terminology. So this is another air crew, and it was an American air crew and I believe Spanish speaking. It was in South America. Air traffic controller, and they were all speaking English, right? Because they do that internationally for the most part. But the controller cleared them directly to the airport. Now, directly means you are cleared from the point that you're at to whatever point you're cleared direct to. So they started that maneuver in the airplane. What the controller actually meant was there is no traffic in front of you. Continue on the flight path that you're on, but you are cleared without delay. And this was a component of a chain of issues that caused them to crash into a mountain, actually. All right, expectations. So once you can set these standards and once you can actually talk about them, then you can sort of set up expectations and responsibilities. You can sort of derive that. So this is things like, what happens if you lose a radio? What happens if you lose an engine? There's a set of expectations that pilots have that controllers will take care of if that situation happens. And controllers have expectation about where pilots will go if this actually happens. So that's really important when you have all of this set up, is you can start to sort of have a closer expectation with your colleague about what will happen in these sort of operational incidents. What sort of operational behaviors will you both do in this situation? As an example of expectations that broke down, this was an incident in LaGuardia a couple of years ago, and the captain took over the flight controls at about 400 feet, and he didn't use the process that you're supposed to use for that. That is really violating an expectation. And of course, you can see the plane, it didn't crash, but it had an incident when it landed. Now, what's interesting, I think, about this specific incident is the pilot was let go or fired from Southwest the next day. Like, that violation of the expectations in the cockpit crew was so egregious that there wasn't even really an investigation. They just said, we don't want you flying for our airline. Kind of interesting. And then remediation. So when you have these expectations and responsibilities clarified, you can sort of start to design remediation processes into incidents and issues that you have. Right? You don't have to invent them on the fly. So the example I give, right, this is an approach procedure. If you're flying into SFO and there's an elephant on the runway for some reason, they have to send you around, they can just say, fly the missed approach procedure, and the airplane will do what's in this plate. They don't have to say, climb to 800 feet, all right, turn left heading to blah, 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 and then turn right heading and vector them around. They will just follow the procedure, right? So they don't have to figure out that procedure on the fly when the elephant's on the runway and they're trying to get it off the runway. They can use that attention that they have to deal with the problem as opposed to try to coordinate all of these things. Now, I want to talk a little bit about what it is not, because a lot of people might say, oh, well, this seems like there's no flexibility. Seems like it would take all of the fun away from all of this. So it is not static. And the example, the example that I give is I think a lot of times we think process means you can't deviate at all. And I'm reminded of a quote from my flight instructor who used to say that the flight plan that you file and the flight plan that they give you as a clearance and then the thing that you actually fly oftentimes are not the same thing at all, right? So it doesn't mean that you can't deviate. In fact, there is a rule in an emergency situation. If you declare an emergency, you can act, and you use those words. There's actually a rule that says you can break all the rules if it results in a successful outcome. And it's not written like that, but you can break the rules to try to improve your chances. So in an emergency situation, it's not saying you have to, conform to all of these rules. The other interesting thing is because of that, they want you to call out deviations as you make them so that the entire system can assess risk. And this actually happens a lot in a weather situation. This is an interesting video. So this is FedEx in Memphis. Those are FedEx planes going into Memphis. And you'll see as the storm gets a little bit closer, what happens, right? It's a very evolving situation, and it's kind of funny. What you see everybody kind of do there, right? Whoa, okay, bye-bye. Yeah. So it doesn't mean that it's static. We work in a dynamic system, they do as well, and so that's how they handle it. Blind reliance on automation and tooling or process. I like to call this Mr. Automate Everything Man. Who's seen this, right? Automate all those things. Well, automation can actually lead you astray, and this is something I actually spoke about this just last week, about release engineering and automation. I don't think we've internalized this yet. There's years, about 30 years now, of research on the aviation side about problems with automation. Now, automation isn't bad. We used to have 3 pilots in big aircraft because we needed 3 people to do the work. Automation has reduced that to 2 people. So it's important, it's useful, but there were a string, and there still are automation accidents or incidents that aviation faces, and I don't think we're there yet. I think we're here. Yay, automate everything, and we haven't sort of realized that. So a couple of examples here. A 737 has an engine disturbance, and the pilots were new to the aircraft type. And they shut down the engine they thought was having the problem. They looked at the wrong gauge when they did that, and it turns out that they had shut down the good engine. The bad engine kept producing thrust until it stopped producing thrust, and they landed about 1,000 feet short of the runway and crashed, or kind of crash landed. This is, we're probably all familiar with Air France 447. There's a lot of meat to that accident. There's actually a lot for us to look in that accident, but you had an instrument freezing over, the autopilot disconnects, the pilots act in different ways, and there's not great communication in the cockpit when they're doing that. Some of the automation in the aircraft is a little flawed in how it communicates what's happening to the pilots. They were trying to work on the automation failure instead of flying the plane, and of course, we know what happened with that. Now, this happens all the time. They call it automation surprise. This is a case from a couple years ago in Paris where there wasn't a crash, but they got outside of the operational envelope much more than they had really expected. If you're curious about this, I just watched this video last week. There's a video on YouTube called Children of the Magenta. And it's a video from American Airlines from 1997. And they're talking about all the ways that automation can mess you up. What's interesting is that a lot of the things they talk about are actually things we run into every day. So they've been talking about this for a really long time. Finally, what is not fun, forbidden. So when they were testing the 787, Boeing did a flight test across the United States in the path of a 787 and the Boeing logo. So this does not mean that you can't have fun while you're doing this stuff. So how do you get instrument rated? Well, you sort of need to define your vocabulary and process primitives. So what I mean by that is you need to understand what you do today, right? You need to define what you do today. So you could have a weird process with all these loops and procedures and whatever, but if you don't understand what you do today, you can't have that conversation about what process primitives you might have, right? And then, of course, if you can do that, then you should talk about that and define or derive your primitives. And then really talk about your organizational dictionary. Things are different at different organizations. But I can tell you, in my experience as a release engineer, it's interesting when you watch an ops person and a dev person trying to talk about what they think is the same thing, but they're using different words. And they spend way more time communicating about it and not understanding what the other is talking about. And then you have to make sure this stuff is owned. So I mean owned by a person, not a team but a person who's actually responsible for doing this stuff. Transition towards systems thinking. So you need to examine flows of communication, code, and data. So what you see now is a really big focus on value stream mapping. That's basically what that is. Looking what the path is from commit through testing, through whatever process you have out to that feature generating value for the customer. What's that value stream? That's basically what this is talking about. You need to review local optimizations. One of my favorite stories here is how many, I worked at a company where all the developers got new big workstations to do their work, and literally, operations had been given a list of things to install. Literally every developer wiped that machine on their first day to install what they really needed on the machine, right? That's a local optimization, so you need to review that and figure out how you're going to deal with that if you're looking at things from a systems thinking perspective. Drift into failure, I actually want to talk a little bit about this because it's an interesting concept. You need to be aware of this idea of drift into failure. So there's an interesting accident, ValueJet, where the plane broke up in flight, and the reason it broke up is because they had put tires into a cargo hold and they caught fire. The thing is that cargo hold didn't have a fire suppression system in it because it was unpressurized. So they thought, well, there's no air there. Nothing can burn without the air. Well, another contractor put the little oxygen canisters that go above the seats, put them in the cargo hold. So the canisters fueled the fire, right? This is another really interesting case. So the short version of it is Alaska Airlines. They had a part that when it was originally certified, was certified to be reviewed every 300 hours. Through a bunch of different processes, in fact, I'll show that here, that approval or check process was raised to about 10 times that amount, right? 3,000 hours. Now the point here, and this is the point of drift into failure, it's not like somebody said, let's get it from 300 hours to 3,000 hours. Nobody made that decision. What happened is over time they said, well, it's reasonable to ask for an extension, that first one. And then there were some definitions in the way that they changed things, so they got more time. And it got to the point where a part that should have been, maybe it could have done every 1,000 hours was up to 3 times that. And then it failed and the aircraft was lost. Now, the point I want to make with drift into failure, we can talk about it as a concept. This is what it looks like on paper. This is what it looks like in real life. It's this feeling of everything is fine. It's something you've seen a bunch of times before, and then right when your expectations are, you get something like that, right? This is what it feels like when we drift into failure. And the only real way to sort of deal with this at all is starting to think about things in systems. So understanding current limitations. So for organizational change to even be a possibility, for us to even really talk or think about that, we need to understand the current limitations, right? And we need to, of our organization. And I think that's actually a problem that we see with DevOps transformations all the time. It's like, hey, we're changing the culture, we're changing tools, and there's not a real good thinking or view about what are our constraints. What are our technology constraints? What are our people constraints, right? So these are holding patterns, right? And one of the interesting things that I want to, if you're familiar with lean at all, lean concepts, Kanban, the holding patterns is just work in process or work in progress, right? What's interesting about holding patterns, though, so if you know lean, if you know Kanban, you know WIP, work in progress, is bad. But what's different from like factory work in progress, where things pile up at stations, widgets pile up, right? Because you don't have a system that's optimized. Planes have kinetic energy. They're going to land one way or the other, right? And that means that when you put them in a holding pattern, they're more complex than something like widgets on a factory floor because they have that energy. It's the same thing with patches, right? If you think about it, if we've got patches or long-lived branches and they're out there for a long time, what happens if they're waiting to be reviewed? We might have to do merge conflict. We might have to test them again because the system changed, right? So whipping both is really bad. This is why, by the way, why understanding your current limitations is so important, because a lot of times you can get situations like this if you don't really understand your current limitations. So investigating outcomes, oopses will happen. They had to swap insurance information after that. I'm not going to talk a lot, actually, about this here, mostly because this dovetails really nicely into the other presentation about failure as success. So if you're interested in this stuff, you can read the bullet points, obviously, but if you'd like to talk about it or learn more about it, that's tonight at 6:15, right? Hopefully, I've convinced you that looking at the National Airspace System as a model of how to do things is worth taking a closer look at. But if you really take away only one thing from this, it should be that if you are going to have an operational model for your DevOps transformation, you need to think really hard and long about incentives and human factors. And you should really ask yourself, well, what does it mean if I wanted to get our team instrument rated? Thanks.